Thank you. Is this working? Can you hear me? Excellent. All right. Thank you so much for coming. I know it's late in the day. I'm always tired by this point, so hopefully I can survive this talk and you can as well. Into the darkest days, zombie behavior tech. Before I get started, I just want to do a little bit of housekeeping. I have some medical conditions, which means there's a very small chance I will have a medical episode during this. I'll give a signal to Guy and Mike, and they will take care of me and of you, so don't freak out if that happens. I'll give a signal, it'll be chill. Great, that's me. I didn't think the screen was going to be so big. I don't like having this massive picture of me, what I look like when I wake up in the morning. So I'm a senior programmer at PikPok. I've been there for 7 years now. It was my first job out of uni. I actually applied for the job the day of my final exam. And for the last 4 years, I've been working on Into the Dead, Our Darkest Days, specializing mostly in NPC AI. I'm obsessed with Mass Effect. I've got over 1,000 hours in the franchise. It's not healthy. And I'm in my friend swap era. I'm really enjoying Peak at the moment. And I'm also a Lethal Company fan. So a little overview. I am going to talk about the AI tech behind our game. I will show a video demoing some of the AI tools that we've made in Unity, and then there will be time for questions at the end. So, Into the Dead, Our Darkest Days. I like to think that you've all played it, but just in case you haven't, it is a 2.5D side-scrolling shelter survival game where you scavenge for resources. It's set in the weeks following the beginning of the zombie apocalypse, and the player needs to use a mix of stealth and combat to deal with enemies. And just to give you more context, I've got a short trailer of the game to show you. Wishlist now. So, what are the zombies in this game for? Well, it's an action horror game, so they need to be scary, they need to be intelligent enough to actually feel scary, and as well as that, pose a danger. It is also a stealth game, which means the detection of the player needs to feel fair. You shouldn't feel cheated if you break stealth, but you also shouldn't be able to get away with anything. And that means we need to support a nuanced awareness of the player based on realistic sensory detection. So, this is the tech that hopefully is making that happen. I'm just going to be skimming over everything because this is several years of work and I don't want you to be here all night. So here is kind of how I break down the AI brain in my head. We have external stimuli. This is stuff happening in the world that can be sensed. So things like the player shooting a gun, making a lot of noise, being able to see the player, or the sensation of being punched in the face. It's a pretty important one. That gets sensed by the low-level brain. Its whole job is to seek out that information and remember it. That then gets fed into the mid-level brain, which processes and organises that information into something that is usable by the high-level brain to make decisions with. And then that all comes out into physical action, which is what the player can see. So I'm going to go through all of those brain tiers, starting with the low-level brain. So this is just the lizard brain. Its whole job is to detect the things in the world around it, and it has sensor units for each type of sense that we currently support. So we have sight, which is performed just with a sphere cast over a range to see if it picks anything up, and then a ray cast to check if it's obstructed. Then noise, this is just the position relative to a noise source. You can see on the gizmos here, as the player's walking along these nice big circles, that represents the noise that they're making. So if they're within that range, they can hear you. Touch is just through overlapping colliders, and damage is processed through our character systems. And memory, that simply stores those things that we sense in a buffer, and after however many seconds that gets flushed out and forgotten. Cool, so that's pretty straightforward. Next up is the mid-level brain, which is actually probably the most complex tier. So starting with stimulus entity tracking. This is basically where we put memories from what we've sensed into a bucket based on what we perceive the source to be. So for example, if I'm over here and I'm a zombie, and the player is behind me, shoots a gun, bang, zombie hears that, that's one memory they've got. They turn around, they see the player in the same place as where we heard that noise at about the same time, so we say, I think these things are connected. I'm going to give them more importance as one whole than I would as those two separate things. Another thing that we use these for is kind of remembering the same entity. So say the player runs away from me, I lose track of them, but then I see them again later. I know that this is the same person who pissed me off slightly earlier. Next up is triage. This is where we kind of determine how important and relevant each memory is. And we create a score for each memory to indicate that. So that's calculated with several things in mind. The type of stimulus, so damage should be considered more important than noise, for example. The time since we sensed it, so newer memories are much more important than older ones. The distance from the NPC that the stimulus came from, and also the source faction of the stimulus, and that allows us to prioritize the player over, say, other zombies. And the stimulus entities, those buckets of memories I was talking about, they have the scores of all of their memories summed up to kind of indicate, okay, how important is this particular entity? Next up is alertness. This is kind of your unalert, aggro, searching, and everything in between. And how we calculate this is by summing all the scores in memory for each sensor. So we'll have a sum for all of our noise scores, all of our sight scores, etc. And if a score for a sensor is above a threshold set by design and data, we increase a transition value between 0 and 1 from one alertness state to another. So say I've got unalert here, and I've got aggro here, and my threshold is like 10 points. My sight score hits 20. We gradually increase this transition, and if it goes below again, we hold for a second in case it goes back up, and if it doesn't, we head back down. But once that value hits 1, that says we can change to that state of alertness. We can go into aggro. And different types of sensor map to different states of alertness. So for example, noise should only set us into a searching state, whereas sight or damage should send us into aggro. Just gonna take a little sip of water here, so I'm not croaking in 10 minutes. Targeting. This is kind of just where we pick, like, who is it, what is it that I'm currently most interested in, where am I going, what am I attacking? So to do this, we select the stimulus entity, that bucket of memories, with the highest score sum for a specified sensor, depending on our state of alertness, which the high-level brain can then use to move to attack. We use the first sensor in a prioritized list that has actually sensed something. So in aggro, that would be damage first, and then touch, then sight and noise, depending on what we have. And we can also have temporary targets for things that are sort of in the way of the main target. So you can see here, There's our player character. They've got this lovely bullseye gizmo saying, I'm the main target of this zombie. There is a door here that is in the way, so we detect that and we make a temporary target, this blue one, to say you need to overcome this obstacle, destroy this door in order to get through to your main interest. Cool, that is the mid-level brain. Moving on. The blackboard, this is just a dictionary basically of hashed strings to arbitrary objects that the high-level brain can use to access references to AI systems like the targeting systems, sensory systems that it might want to use. And it also stores references it stores like variables, so things like have I ever been aggro, what is my next attack type that I've selected, just anything you want. AI tasks. These are the building blocks of all of our AI behaviour. They are scriptable objects and they can be either an action or a condition. They have access to the blackboard, so all of that information they might need about the AI. And they just have an execute function that returns either running, failure, or success. So starting with AI action, it does something. It does whatever you want it to do. It could set inputs to tell the zombie to attack or move or whatever, path to a target, wait for a while, equip a weapon. So they can be instant or run over several frames as well. So here's I'm really sorry for blinding you with light mode. There are dozens of us. Here's an example of one, setting the melee input down. So this is just telling the character systems I want to do a melee attack. Because it's a scriptable object, we can just have a serialized field up there, which makes it really nice and easy to configure the action to do. And then on initialize, we get from the blackboard a reference to the character inputs. And on execute, we set the melee down input. It's pretty simple. And then on the flip side, we've got conditions, checks if something is true or false, as you can imagine. Like, for example, do we have a target? Is the target visible to me? What's my current alertness state? And these can also be composed in or and conditions, which themselves are also AI conditions, which allows us to create more complex conditions. So light mode again, sorry. So at the top there is the abstract condition AI task. It's got a serialized invert bool, which means we can quite easily flip the result of whatever we get back. And then here's an example of a concrete one, which is checking if we have the target. We've again got a nice serialized field about what kind of target type we're checking for. So for example, the main target or a temporary target like a door. On initialize, we get the targeting system from the blackboard, and then on evaluate, we try and get our target from the targeting system and return whether it has a target. Cool, all right, this is where it all comes into use. So, the hierarchical finite state machine. This is a state machine where every state is itself a state machine. So here is a kind of high-level state machine which has a state for sort of all our different states of alertness. So we've got our aggro state, unalert, patrol, searching, and this, because I've taken this at runtime, it's highlighted the active state that we're in, the aggro state, and that big old arrow points to the state machine that exists inside that one. So while this aggro state is running, this other state machine underneath it is handling things like, am I currently going to the target? Am I currently breaking an obstacle? Is the target on a ladder and I can't reach them? Etc. And the states run those AI actions that I was showing you before. They can have a list of things to run on start, on update, on stop, and on exit. So for example, here we've got the aggro state, and on start, it tells the alertness system, okay, I'm aggro now. It starts sprinting, and then on exit, we stop sprinting. We say that we've exited aggro, but you can put any sort of action you like in there. And then the conditions come in on the transitions between the states. So if here's an example, we're going from aggro searching into aggro. We check, are we ready to transition into aggro based on what the alertness system tells us, and is the target actually not dead? Cool, next is the behaviour tree. This is a pretty widely used concept in game AI. But what is cool about this one is it uses those exact same actions and conditions, which means pretty high reusability, which is really great for just neatness and consistency and programmer time and design time. So yeah, we can see these green ones are our actions and these yellow ones are our conditions. And of course we have other standard behaviour tree nodes like selector and sequence and repeat. And running a behaviour tree is itself an AI task, so the state machine can run a behaviour tree from a state, and even another behaviour tree can run a behaviour tree, which is quite cool. Cool, and the physical action. So when the player is playing the game, they have their controller and they push this button to set a melee down ball somewhere. They set their horizontal axis with the joystick. That's how the player's inputs go into the character systems. For the AI, they have that exact set of inputs and the exact same character systems, but the inputs, instead of coming from, say, a controller or a keyboard, come from the high-level brain, so a behaviour tree, for example. Which means, in theory, an AI could do anything that the player could do, which is really, really cool. So yeah, those inputs can be set with those AI actions I showed you before, for example, and we do also have behaviour trees specifically for more complex kind of traversal actions like climbing ladders or going upstairs. Cool, so we've sort of left that flow chart I showed you at the start of the AI brain, but there are some other notable systems that kind of an important framework for allowing the AI to do what it does. So, starting with traversal. So Unity has the nav mesh tech, which is where it sort of produces a mesh on the ground of where an AI can walk and handles all of the pathfinding for that. But that's more suited for a fully 3D game, whereas our game is 2.5D. It's really important for our characters to stay on a specific Z position. We don't want them, ending up sort of off by 10 centimetres and suddenly able to run past things they shouldn't and not be able to hit a zombie because they're just a little bit offset. So for this reason, we made a bespoke pathfinding web system. It's just a graph of nodes and connections. So those nice spheres there in the gizmos are our nodes, and the lines between them are our connections. And we add node generators on prefabs that are relevant to traversal, like stairs and doors, that mean once design has set up their level, put all their stairs and doors in the rooms, they can pretty much just press a button and the web will automatically generate. So the AI will generate the path to target position using an A-star algorithm, and they just keep moving to the next node in the path until they arrive at the goal. So if I've got like 3 nodes here and I'm the AI here, I move to this one, and once I'm almost there, I look ahead at the next one, move to that position, and so on. Connections between nodes on the pathfinding web have flags indicating what type of traversal they represent. So for example, stairs and ladders, jumps, ledges, that allow us to kind of define where certain AI can go. So for example, zombies aren't allowed to climb ladders, but maybe our humans can. Nodes and connections can also have obstacles, which can affect the path the AI may choose to take. So for example, if we have a room with a door at either end, and we've got just an unalert patrolling AI, we want them to be able to walk between these 2 doors, but we don't want them to try and break through one just so they can move 10 metres to the left. But when they become aggro, we say, okay, you can go past doors now, and they can use that to smash down a door and get the player in the next room. We do actually use the nav mesh though, because of the 0.5D aspect of 2.5D. We have zombies who live initially in the background or the foreground, and once they're alerted by a loud enough noise, for example, they project to a position on the pathfinding web that is in front of them and use the nav mesh to navigate to that position. Something that's quite neat is that we actually use the pathfinding to simulate a semi-realistic travelling of noise through space. So for example, like you don't want to just detect noise as the crow flies. You want it to seem like it's being occluded by walls and ceilings. So if I'm a zombie here, there's a character a metre away from me, 2 metres away from me this way, and 2 metres away from me above me, on the floor above. I should hear a noise that this character makes louder than I do the one above me. So what we do is we just calculate the distance that the AI perceives the noise to be from them by doing a pathfinding algorithm to see, what is the shortest path to the source of this noise, consider that to be the distance that they are from me. And we can also add multipliers to nodes to dampen the noise. For example, a closed door should occlude some of that noise. So you can see here I've circled this 0.5 on the door. That says this door is halving the perceived noise. Whereas over there's a door that is open and that's had the multiplier removed. Noise should be able to pass through freely. Cool. Queuing. This is how AI arrange themselves around a target. Anything that can be targeted by an AI for attacks is surrounded by what's called a queue join area, which is just a small path generated on either side of them on the pathfinding web. You can see in the gizmos here, we've got this big green rectangle around the player. You can barely see amongst all these zombies. He's wearing a hat. Once an AI enters that queue join area, they get assigned a queuing slot. So that's those spheres you can see there. And then they path to that position. The slots can allow different kinds of attack depending on the size of the queue and how close the slot is to the target. So in this example, those green spheres are attack slots and yellows are ones that can't attack because, for example, they're too far from the player. And as the queue grows, the distance between the slots compresses so more zombies can hit the player. Because if you're in this situation, you've messed up and it's better if you die quickly. And you can actually see it on this side of the player. There are only 3 slots. On this side there are 4, and I think you can tell the 4 are just packed together a little bit more closely. And this also kind of creates a feeling of like claustrophobia and just terror for the player. Target sharing, I really like this one. It's a way of zombies being able to share information with each other. And the way we use this is we have certain zombies who, when they spot you, they will scream in terror and wake up all of their friends around you. It's a really exciting and scary moment in the game. So what happens is they create a noise of their own and they attach the information of their current target to that noise so that when other zombies sense that noise, they have this target information, they add it to their own systems, and then they can go and target whatever that other zombie was targeting, usually the player. Territory. So this is actually more for our human AI, but I wanted to touch on it quickly. This is sort of used for a situation where if the player is out scavenging and they come across someone else's shelter, it's already occupied by humans, you want to be able to walk in the door and have them tell you to go away. So how we achieve this is we mark sectors of the pathfinding web as belonging to a certain faction, and each AI keeps a 0 to 1 value for how tolerated a target is within their territory, where 1 is, okay, I'm going to start attacking you now. And the value increases at a rate depending on how deep the target is within that territory. So Like I said, if you just walk in the front door, they might politely ask you to leave. But if, they turn around and you're in their bedroom, they should probably freak out a bit quicker. Cool, so that is the tech overview. I do have a video showing or demoing some of the tools that we've made for the high-level brain stuff. I have to come clean about something. This is a slightly recycled version of a talk I've done before on a Unity live stream, and I have just cut out the same tools demo section from that, so I will allow you to watch that. Also embarrassing, I'm wearing the same outfit in this video that I am in real life. I know I'm a programmer, but I promise I do have different outfits, so here we go. It's about 8 minutes long, so settle in.
So let's make a new one called Unity live stream. Boop. Cool, so we've got this beautiful empty canvas to use. Right click, make a new state. Let's, I don't know, what do you think, James? What kind of behavior should we make today?
Chillin'.
Chillin'? All right, let's have a chillin' and one for not chillin'. Awesome. And we can see these little ports at the top and bottom. We use those to make transitions. Nice and easy. So if I click on this chillin' state, I can write a little description. I'm just hanging out. And that shows up on this node. It makes it easy to kind of take notes and explain what's going on for reference later. And maybe on start, what do I want to do? Let's make this a bit bigger. I don't know, what should we do on start, James? Not equipping a knife because we're chilling.
Well, yeah.
These are just all of our actions. Let's just wait. You're chilling. You just wait. And it's not showing up for some reason. Oh, I know why. It's because it's a task that needs to be an update. Like I said, you've got instant ones and simulated ones. If it's stimulated, it goes an update. Wait. Let's wait for like 5 seconds. Sweet. And not chilling. That's when we equip the knife.
Equip the knife.
Oh,
yeah,
yeah.
get it.
Yeah. Cool. Now we've got our 2 states, and we can click on our transitions and set something up. So maybe if we're going from chillin' to not chillin', it's because we are ready to go into aggro. So let's click this alertness transition ready, and then from not chillin' back to chillin', we'll do the same thing for going ready to go into unalert. Cool, and it's hierarchical, like I said. So if I double click, we've got a brand new state machine to play with. So I'm chillin', and maybe I'm chillin' by the pool, and maybe I'm chillin' on the PS5, and we can have transitions between these, and we set that up, and we can also make a reuse another state machine. Like it's pretty modular, so I can just pick any other state machine. Let's see, what would be a good flavor idle? I don't know what that is, but that sounds chill, and we can go into that like any other state. And we can also make a behavior tree. Let's actually, I'll just let's see what would be a behavior tree that we could run when we're playing the PS5. Let's see. We'll just we'll update our target because we we might be playing a shooter. And then if I click on this, it's going to open that behavior tree. And actually, if I click on this, it's going to open the state machine. So let's make a behavior tree. What should I call this one, James?
Shooting folks.
Shooting folks. Perfect. Cool. So let's see. What are we going to do? We're going to maybe make a... what should we? Let's make a sequence. We do the same thing. We just drag from these ports to connect stuff, let's make an action. So because it's a sequence node, it's just going to run everything under it left to right. So what do we do first? What are we doing? We're shooting. So let's equip a ranged item. That's a gun, whatever gun we have equipped. And then I don't know if we have an action first shoot input yet, because our AI doesn't actually know how to use guns yet, I think.
It pretends. It's just doing it.
Yeah. Fire, do we have? No, I guess we don't. We'll just, I guess they can pistol whip you.
Pistol whip.
Yeah.
Perfect. And then we can make some conditions. And maybe, if we're feeling, maybe if we're aggro, then we can maybe yell as well. Do a bark. That's what we call the little speech bubbles. Yeah, let's do this one. They're probably yelling something angry there. So that's kind of the idea of the tools. So here are all of our zombies. We can see our pathfinding web. We can see our nav mesh. Let us click on this gentleman. So you can see he's in this patrol state. If I just bring this up, let's hop in. I've got this button which is really handy, jump to deepest active state instead of having to double click into everything.
Super handy.
I can just hit that and it'll take me to just the deepest active state. So if I go back out, we're in this unalert patrol state, and this is running the zombie patrol behavior tree.
Cool.
So let's make this guy a bit bigger. So here it is, and we can see in real time the nodes highlighting to show what we're doing. So if I zoom out a little bit. So the patrol behavior, what they do is they generate some parameters of like, what direction am I going in? How far should I patrol? And once they've done that, they wait a second. So if we just keep an eye on those nodes and on this zombie, yeah, we can see it. It's moving, and then it will do a little wait. Just let it wait. Or it reaches the end of the room and it waits. So here we have the blackboard. This is something else we can look at in real time. So I've still got this one selected. Actually, I might change it to this one because they're in a handy spot. So if I open up this character's sensory system, we can look at all their memories. So here's some noise. This will be the player character's footsteps probably. Sight. We've got a decent score there because we can see them. They're in our sight cone. And we can open that up to see more information about it. Do that for all of them. What position it was at, the faction. More noise, probably a different footstep. Touch, except we've just kind of run into them. And damage, of course, has that nice big juicy score. And we can open our stimulus entity tracking. This is its understanding of the player, and it's got like all of these sums for like all the sort of triage scores for each different sensor, position, all that information. I showed you this in the slides, so I don't need to show you too much. Alertness system, it's already in aggro, so not a lot will be going on in here. But here we can see all of those 0 to 1 values to figure out how close they are to changing. Yeah, that's probably enough of that. I think that's it.
Sweet, okay. So that is basically the end of the talk. I just wanted to share some references. I really recommend taking a photo of this. So these were really informative for our development of the AI in this game. So this Martin Walsh talk from 2014 about Splinter Cell Blacklist taught us about the idea of simulating noise traveling through space along the pathfinding web. This AI Arborist one from 2017 taught us about the concept of the hierarchical finite state machine. And then finally, the Kiwi Coder on YouTube has a really great tutorial about creating a behavior tree editor in Unity. We basically use that wholesale. So if you wanted to make a behavior tree exactly like the one I've showed you, you can follow that tutorial and do it yourself. And then the learnings we took from making that editor also allowed us to make the state machine editor too. So, we made it. Yay. Thank you. And now there is time for questions, if you're confused, like these guys. Yes, someone has got a microphone.
It is on. Hello? Cool.
Yeah.
Hey, I was just wondering, you had two behavior trees open, or maybe like one was a behavior tree and one was something else, and you reusing a lot of assets. How did you tackle the challenge of designers wanting to reuse things but then modify things which were already like in use in other places?
Sure. I think the way we handled that is basically an implicit kind of rule that if you make action or condition asset, you name it very clearly for what its purpose is. So for example, wait 5 seconds. And if you wanted to modify something, you would make a new one of wait 4 seconds and just replace that wherever you want it. So it's sort of just a designer discipline issue, really. Because, yeah, in theory, if you edited one of those actions or conditions, then it will apply anywhere that's using those assets. Thanks.
Hello. In the combination of the stimuli engine that you had going on, and then say things like the group behavior, like the join the mall queue, how did you handle with kind of prioritizing breakouts from those behaviors, you know, between specific targets and then group behaviors they might be overriding?
I'm sorry, it's a little bit hard to hear you. Would you mind just asking that again a little bit slower?
Oh, sorry. So when you have the stimulus creating targets or behavioral priorities for the AI, how did you handle when they have, say, some overriding group behavior they're currently engaged with, but then you want them to kind of super prioritize some other thing on the screen? Did you ever have that, given that there was only one player, or?
Oh, so you mean if there were more than one thing that the zombie might want to be targeting?
For sure, yeah.
So that is actually not something that has been super relevant in what we have out right now. Currently, the only thing they're generally going to be interested in is the player or something that the player has done. But we are actually working on improving our human AI, and that does involve interacting with zombies. So that is actually something that is being tackled right now. So I don't have the answer completely for that yet because it's still being explored. But yeah, it's definitely a good thought. We've got one up here.
Knowing what you know now, do you think that is the best way to go about creating the system, or would you change the system if you had to recreate it in the future?
Do you mean any particular part of the system?
Yeah,
or just the whole thing?
Yeah, any part of it or the whole thing, or does it function the way you wanted it to function without it being too complicated, or?
Yeah, I think we're pretty happy with where we've landed. There's always improvements that need to be made. And I will say, we didn't have all of these systems from the get-go. Like some of these, we started with a really basic version with not all of those systems. And as we went, we found needs for them, like the stimulus entity tracking. That came on slightly later than all those other systems because we didn't realize yet that we needed to associate two memories together to give them a combined importance. So yeah, I think we would probably approach it in a pretty similar way to what we have ended up with.
Hello. I was just wondering what was the motivation in creating your own graph tools instead of using, say, like Node Canvas or another existing asset?
Yeah, sure. So it's many years ago that we started actually doing this work. I do think we looked at existing tools, like there was a little bit of research, but in the end we found that tutorial that I mentioned the Kiwi Coder did a great job, and also it's free, which is a nice bonus. And then also, yeah, it taught us a lot as well, allowing us to extend it and make other similar tools like the state machine editor.
I was also wondering with the memory stuff. What were the particular use cases for zombies? Because I can see it very useful for the human AI in that they need to, like, I guess, abstract complex relationships between themselves, their own faction, and the player. But zombies, a bit stupid. What was the particular purpose in that case?
So the memory, it's not necessarily long term. Like I said, the memories do get flushed out eventually. They usually get processed into that mid-level brain first, but it's kind of short-term memory as well. Like, for example, like I said before, if the player's hair shoots a gun, they need to be able to remember that noise long enough to turn around and say, oh, you're the same guy who shot the gun, and associate those things together, if that makes sense. Cool. Anything else? General questions about the game? About me? What's my star sign? No? All right. Sounds like we're done. Thank you so much for coming along. Really appreciate it.